This video will talk about this new concept of vectors, and we're going to do a graphical approach in this video, but in the next video I'll do a different approach with what we call resolution of vectors. Okay? But first let's define what a vector is. You've learned that most quantities you've learned so far are scalar quantities. So you say I have 30 gallons of water, right? And you just leave it at that. Or you say that I'm going at 50 miles per hour, and you leave it at that. Okay? But in both of these examples, you did not talk about you did not talk about direction. Okay. So in order to define a vector, it's basically a scalar quantity, a number with a unit, and you add direction next to it. So if I say that my velocity is 30 miles per hour, that's a scalar quantity. So this is what we call a scalar. So it's basically a number and with some units, right? And I have to put the units, otherwise if I just say I'm driving at 30 what? Meters per second, miles per hour, kilometers per hour. So I have to have units. Units are extremely important in science. Now, if I give you direction, I have a better description of my quantity. So if I say I'm going 30 miles per hour north, this becomes a vector quantity. So basically a vector is a scalar with some direction added to it. Okay. Now the notation for vectors is just a letter V with an arrow on top of it. And the arrow basically is always pointing to the right, even if the vector is pointing to the left. I label this as V like that. And the arrow just shows that this is a quantity that requires direction. Right. So now since we're talking about direction, on paper or on the board, we have to define east, west, north, and south. So on paper, we're usually going to draw a map, right? A dotted line like this, an X and Y coordinate if you like. So we're going to say the right is east, this is north, left is west, and this is south. It doesn't necessarily mean that the right side of the board here towards the F wing is east. That's not the actual east, but on paper that's what it is, right? So we have to define that. And we also have to define a scale, because if I say that I'm going at 100 miles per hour, let's say east, right? Well, I have to decide how I'm going to translate this 100 miles per hour, or how I'm going to represent 100 miles per hour on paper. So you have to do a reasonable scale that will fit on paper. My scale on the board will be different than yours on paper because I have a bigger size board, paper basically, right? So here I can say, you know what, let's do every centimeter is 10 miles per hour. So now to represent 100 miles per hour, I need 10 centimeters. So if I can fit 10 centimeters on paper, I'll do it. Otherwise, I'll have to change maybe to, say 1 centimeter is 20 miles per hour. Then I will only use 5 centimeters. So this map is important for vectors, and the scale is also extremely important. Okay. So I'm going to have a couple examples here. I'm going to do one of them for now. So I'm going to say V is 20 miles per hour, okay, at 20 degrees north of east. Okay, so what does that mean? Well, first I have to come up with a scale. So I think I could do 1 centimeter, and I'm saying this is on paper. I'm going to say maybe it's 5 miles per hour. And for that, I only need 4 centimeters. So if I do 1 to 1, if I do 1 centimeter is 1 mile per hour, I need 20 centimeters. That's a lot of centimeters. If I do 1 centimeter for 20 miles per hour, that's too small, and if I make an error, it's going to be serious. Okay. So I think this is a pretty decent scale. I can do 1 centimeter to 4 miles per hour. Okay. 20 degrees north of east, this is how you do it. You always do your directions with respect to east and west. So technically, you come to the east, and you go 20 degrees towards the north from the east. Okay? And we draw this with a ruler, of course. So this is my vector V. And this is 20 degrees. It's from the east going towards the north. And that's how we're going to do the measurements for angles. It's always going to be with respect to east and west. Okay. Okay. Now, what's the opposite of a vector? Well, the opposite of a vector only changes the direction. So this is what we call the magnitude. It's just the size of the vector, basically. We're still going 20 miles per hour at. Now, what's the opposite of north of east? So that's down here. Okay, it's 180 degrees away. So this is the angle. So this is 20 degrees, and you can see that from the geometry. And that's south of west. We always do it with respect to the west or east. So south of west. That's the opposite of the vector. Okay? So now let's do some addition and subtraction of vectors. So I have two vectors that I'm going to try here. I have V1 equals 2 miles per hour east, and I have V2. And I'm going to start with the easy stuff here. It's 6 miles per hour east. So V1 plus V2, which sometimes we call the resultant. That's just another way of saying the combination of the two vectors. How do I draw this? Well, here's my map. So I start at the origin, and I go 2 miles per hour east. So let's say after I do the scale, I go this way. And then, to add, I come to the tip, and this is important. I come to the tip of the first vector, okay, and I add the next one. So V2 starts here, and it's 6 miles per hour, 3 times the size of that. Okay, and this is V2. And my resultant is this. Oops, this is no. My resultant is this combination. This is R2. My resultant is this combination. And that's R. So that's R is V1 plus V2. So you have to do head to tail every single time. Now the next one, if it says subtract V2 from V1. So I have to subtract here. Subtracting is the same thing as adding the opposite. So I'm going to do another one here. Well, first thing I have to do, I think, is find the opposite of V2. So that's 6 miles per hour. Okay? Instead of going east, now it's just west. So this is how it works. You start with the first one. So you do V1. And again, you come to the tip of V1. Okay? And you go west. So from here you go 6. Okay? So this is V2, negative V2. And the combination is always from the very first starting point to the very last arrowhead. So this is my resultant. And you can see that and you would measure this, scale it, and figure out the direction. So that's going to be, I mean, this is a simple example. That's going to be 4 miles per hour west. Let's do something that's not going east and west, but rather going somewhere in between the north and the east, or south and the east, and all that. So basically, we're going to do this in 2D. So V1 is 50 meters at 30 degrees north of east. So maybe someone walked that distance. Okay. V2 is 30 meters at 45 degrees north of west. Now, to do V1 plus V2, after you do the scale and all that, okay, V1 plus V2, which is the resultant, we're going to do the map. Now, we're going to need a protractor and a ruler for this when we do it in class. So I'm not going to do, I'm just going to give you the idea, but we'll do the practice in class. All right. I can actually do I can do V2 minus V1. I'm going to subtract V1 from V2. Let's try that. V2 minus V1. Okay, so which basically means I have to find what negative V1 is. So that's going to be same magnitude, okay, at 30 degrees. Now the opposite of north of east is south of west. So you just take the opposite of those things basically. So I'm going to start with V1. So V1 is 30 meters at 45 north of west. So north of west is here, halfway here. And obviously I will do this with a scale, so that's 30. Okay? Now this angle here is 45. Now you come to the tip of this one and you start a new map, but we're not going to do that. We're going to try to use some geometry tricks to figure out the opposite of the V1. So this is V2. So start from here, and you have to go, you get the direction first. You go 30 south of west. So we're going to go in this direction, right? Okay? And we have to go 50 meters at an angle of 30 from here. So this angle here has to be 30. And we'll measure that with a protractor. And we have to go 50 meters. So that's negative V1. Okay? That's how we add vectors. Okay? Head to tail. Now, the combination is basically going to be this. It's going to be from here to here. That's my resultant. Now, how do we figure out the resultant? I measure this length here, and I scale it back down, and I figure out the angle, in this case with respect to west, because this R is closer to west than it is to east. East is all the way back there. And that's how I write it. So I write it as R equals a number with units, in this case meters, and then I do adds certain angle. Okay? And we're going to practice this in class. Okay. So let's say I have, here's an example. Let's say I have two vectors, V1, that has an amplitude of 20 meters. I'm not telling you the direction, I'm just telling you the amplitude. I mean, not the amplitude, the magnitude. V2 is 30 meters. Question is, what are all the possibilities that you will get if you combine these two vectors, if you add them? Okay? So I want you to think about that. Now keep in mind that since I'm not giving you the direction, these vectors can sweep 180, or actually they can sweep 360, right? So the smallest value you can get, and I hope you can see this, is 10. That's when they are going in opposite directions. And I think the highest value you will get is when they are going in the same direction, and that will give you 50 meters. And then you will have everything in between. That's if they go in at an angle. Okay. And I think that's it. I will do some practice in class. All right. See you later.